Hello everyone. In this video, we're going to be solving a number theory problem. ABCD is a 4-digit number, and a squared plus b squared plus c squared plus d squared, the sum of the squares of the digits is 50, and the digits are increased as we go to the right. In other words, D is the largest, A is the smallest. Now, where does this problem come from? Or at least the idea, right? Well, this problem is from AJHSME, kind of hard to say, AJHSME, 1997, formerly known as, the other way around. It used to be called that. In 2000, they started calling it AMC 8 because they came up with AMC 10, AMC 12, so on and so forth. Anyways, we can talk about the details of these competitions later if you're interested, especially if you live in the United States and if you are in middle school or high school. And if you like math, of course, why would you be here, right? Otherwise, anyways, we can talk about it. Let me know in the comment section down below. Let's get to the problem. So we have this problem. By the way, I changed the statement of the problem because I sometimes do, and the problem is asking for something slightly different, but you can definitely check it out. So we have a 4-digit number. We do know that, ABCD. So I simplified the wording a little bit, the original statement of the problem, and modified a little bit, just a bit. So we have a squared plus b squared plus c squared plus d squared is equal to 50. And a, b, c, d are arranged like this, okay? Cool. Now, we're going to take a look at some limitations, or should I say bounds. D is the largest digit. So if you square 7, you get 49. Awesome. Still less than 50. But if you square 8, you get 64, which is greater than 50. What does that mean? That means all the digits are less than 8. Because if one of them is 8 or larger, it's not going to work. We can't have a negative square, can we? Not in the real world, especially in the number theory world. Everything has to be like integer, integer, integer. So, and we can't use 0 either. Why? Think about it, and hopefully you'll get the answer. Okay, if you don't know the answer, I'll tell you, but pause the video if you're still trying to guess. Well, A is the smallest digit, and if we have 0, that has to be A, but then we don't have a 4-digit number. Make sense? Anyways, so we're going to look at case by case, and we'll do a casework on D. So if D is 7, that's kind of like the first case, then we get A squared plus B squared plus C squared equals, if you subtract 49 from 50, you get 1. No way, right? Come on. The smallest digit A can be is 1, and 1 squared, then there's nothing left for B and C. This is not going to work, right? So D equals 7 is not going to work. Forget about it. Let's go ahead and look at the next case. Next. Okay. If D is equal to 6, what happens? 6 squared is 36. Subtracted from 50. Okay, if you want me to write it out, I know sometimes people are like, why did you write things out? And you're going too fast. Okay, slow down. I got to remind myself all the time. So now, if D is 6, this is going to be 36 because you're squaring it. And if you subtract 36 from 50, you have 14 left. Can the sum of 3 integer squares be 14? And the answer is yes. How do you know? Test it out, obviously. You have to try, by the way, if D is 6, ABC has to be less than 6 because they're all different. Have you noticed that? Hopefully. So they can be, and trial and error shows us real quick that ABC has to be 1, 2, 3. It's as easy as 1, 2, 3. Was it ABC? Anyways, 1, 2, 3. Same idea. And from here we get the following number. Since we started off with D equals 6, and that gave us the only option 1, 2, 3. Put it all together, you have 1, 2, 3, and then 6. Make sense? Sum of the squares is 50, and it's a 4-digit number, and the digits are increasing left to right. So you have to satisfy all the conditions. Again, look at the statement of the original problem. You'll see some slight modifications. It's also a good problem. Anyways, so let's continue. D equals 5 is the next one. So if D is equal to 5, then we have A squared, B squared, C squared. Remember, you're supposed to square 5, which is 25, and subtract it from 50, and that gives you 25. Can the sum of 3 squares be 25? Well, first of all, if D is 5, C is going to be 4 or less, right? If C is equal to 4, then that's going to give you 16, and subtract, you're going to get a squared plus b squared is equal to 9, which means b needs to be 3 and a needs to be 0. This is not going to work. A can't be 0 because then a, b, c, d is not going to be a 4-digit number, right? Well, in some cases with computer problems, you pretend, but come on, this is mathematics, not computers. It's serious stuff. Okay, so a can't be 0, too bad. What's the next case? D equals 5. I mean, d equals 4. You know what I'm talking about. If d is equal to 4, then we get a squared plus b squared plus c squared. Because 50 minus 16 is 34. This is going to be 34. Great. And again, this is the minimum value for d, because think about it, a, b, c, d. If d is 4, this needs to be a 3, this needs to be a 2, and this needs to be a 1. There's only one case that works. But wait. If you just add these up, it's going to give you 1 plus 4 plus 9, which is 13. Uh-oh, it's not going to reach 34. Too bad. We used d equals 4 and it didn't work. That was the minimum value. That kind of restricts the ABC, so you don't have a lot of room. Make sense? So the general idea for this problem, I gotta tell you, with a lot of digit problems is to kind of finding upper and lower bounds. In this case, this happens to be the case, right? If d equals 3, we don't have a case because then one of these have to be 0. I mean, a has to be 0, right, in that case, and that's not gonna work. That's why this is the minimum, and we have to stop here. Okay, if you're doing casework, make sure you don't come up with too many cases, especially with combinatorics problems, which I'm not a big fan of, by the way. That's why I'm not really doing it, but hopefully you don't like them either, right? I mean, they're too complicated. Anyways, so I'm kind of more like an algebra guy, you probably noticed. But with combinatorics problems, if you're doing casework and you're coming up with too many cases, you know what that means? That means you shouldn't do casework. You should do something else. Maybe inclusion, exclusion, who knows? Something else. Okay, great. So hopefully that helped, and d equals 4 did not work. So what is the conclusion here? The only number that satisfies this equation is 1, 2, 3, 6. And I'm going to leave you with a question, and I'll definitely encourage you to look at the original statement. I could probably include a link, again, if I don't forget. If I forget, please remind me to include the link for this particular problem, because you can find it on the web. But basically, my question would be, can we find the 5-digit numbers that satisfies the requirements? And you'll understand what I'm talking about, hopefully, after looking at the original statement of the problem. Anyways, this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video, right? And until then, be safe, take care, and bye-bye.